There it goes. Cube root, is that the other one you said?
Yes.
Cube root, your points are -1, -1, 0, 0, and 1, 1. And to remember, a cube goes like that S shape. A cube root looks like this snake shape. That is your reciprocal and cube root. Okay. Describe the transformations from the parent function. So this is remembering what is the parent function and what do I do to that parent function when I moved it. So like, for example, this one, number one, my parent function is 1 over x. Okay. The negative outside means I multiply the y by -1. The 5 means I multiply the y by 5. The 7 means I'm going to go left 7 and then down 2.
Hey, Coop, I have to go.
Okay, bye, sweets.
Bye.
Me too.
Me
Have
too.
Bye, guys. Yep.
See you, Coop.
All right, so like on 2, remember this one means it flips the x, and the 2 inside means you divide the x by 2. You divide the x by 2. All right. We good on that one? You won't have 4 or 5 on there, so it's fine. Oh, okay. So write the function graph and then state the domain and range. So a quadratic function is reflected in the x-axis. So it's reflected in the x-axis. Remember, the x-axis is your horizontal axis. So it's reflected this way. So it means the y's change. So it means negative goes up front. Vertically stretched by a factor of 3. So it's going to be -3. And then x, it's translated left 4. So +4, the quantity squared, and up 6. So that's how you would write the function. And then you would, to graph it, remember those 3 points. So -1, 1, flip, multiply by 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, something like that. Oops. So your function's going to look like so. Oh, I guess I could have done it down here. All right. Topic 2. Oh, symmetric. So remember, if it's symmetric with the x-axis, you have that plus or minus y value. It's the same. If it's symmetric with the y-axis, plus or minus x, and origin is plus or minus x, plus or minus y. So what that means is, if you look at the graph, you can tell it's symmetric with the x-axis just by the graph. It's not symmetric with the y because it doesn't fold over nicely. So, and then origin, if it's the x-axis, you would do -y squared minus x equals 4. Y squared minus x equals 4. These are the same. So that means it is symmetric with the x-axis. Y-axis, you would plug it in for x. So y squared minus a -x equals 4. That becomes y squared plus x equals 4, which is not the same, which is why it's not y-axis. Okay? And if it's not y-axis, it's not going to be origin. Even, odd, or neither. It's an even function if f of x is the same as f of -x. It's odd if f of -x is the same as negative f of x. Okay, and then you just find it. So if I were to find f of -x, plug in a -x, so 3, 2, -x squared minus 9, which is the same. Then you square negative, it's still positive. Since these are the same, this function is even. Those functions are even. Determine if the function below is continuous or not. So what it means is if I have to pick up my pencil. So if I'm running along this graph, I have to pick up my pencil. So this is discontinuous. Oops. And it has a hole at x equals 2. Has a hole at x equals 2. Where 14 is continuous. You don't ever pick it up anywhere. Okay. 15 is discontinuous. Now this one, I would accept vertical asymptote, but it's definitely called an infinite discontinuity. And that's at x equals, where is that vertical asymptote? You can draw it in if you want. At x equals 3. And 16 is also discontinuous. You have a hole right there. Okay. All right. Topic 3, operations and compositions of functions. So g minus h of x, all that means is you take g and subtract h. When you divide, it's the same thing. F of x divided by h of x. When you multiply, do not confuse multiplication with composition. If it's a solid dot, that's multiplication. Or if it's an open circle, that is when you compose it. You put something into something else. So on 21, if I put g, oops, that should be an x instead of an h. If I put g into h, so g is right here. I'm putting that into h, so it's going to be 2. Instead of x, I replace it with what g is. So you have 6x squared minus 4x minus 10 minus 1. So 6x squared minus 4x minus 11. Okay, that is composing functions, putting one into another. Same thing here, inverses. So determine if the graph represents a one-to-one function. It's one-to-one if it passes both the vertical line test and the horizontal line test. So this is one-to-one. Whereas this one passes the vertical, but it doesn't pass the horizontal, so this one is not a one-to-one. This one passes the vertical and horizontal, so this is also 1, 2, 1. Okay, also 1-to-1. How do I find the inverse? That means you switch your x and y and solve for y. So this is going to be x equals the square root of negative y plus 6. Square both sides, so x squared equals negative y plus 6. Subtract 6, so x squared minus 6 equals negative y. And then multiply everything by negative 1. There is your inverse. You technically should probably write it as f of x to the negative 1 equals negative x squared plus 6. Does anybody want me to go over any more other than the ones I just did?
Yes. Can you go back up real quick to
Yeah.
right there, I think. So number 21. Can you show me how you did all that?
Yeah, I'll do the next one too. I'll do 22. I'll do a composition. All right. So this is written as f of g of x. So that means I'm going to put g into f. Okay, so that means this right here goes in for x wherever you see it in f. So this is going to be 4. Instead of x, I'm going to put 3x squared minus 2x minus 5 minus 1 over, sorry, I have a hole in my screen doesn't work right there. I was just stupid. 3x squared minus 2x minus 5 and then plus 1. So this should be squared. Now from here, Dylan, you would square this and then just simplify it. You would square it and then just simplify it.
Okay.
Does that help?
Yeah.
Okay. Any others you guys want me to go over? I would suggest you just kind of pick and choose, like do some, make sure you're getting them right. And then, you guys can see what you need to ask me tomorrow, because I'm not going to answer any questions on Monday.
Is number 12 an odd?
Yeah.
And what does that mean by f of negative x equals negative f of x?
Okay, so I want to prove that it's odd. You need to find f of negative x first. So this would be the cube root of 3/5 times negative x. So this is the cube root of the cube root of negative 3/5 x. Now, this is not the same as my original. So then I need to find the opposite of f of x. So that would be the cube root of, or the negative cube root of 3/5 x. Now, here's the deal. When you have a negative inside a cube root, you can kick it out because the cube root of -1 is just -1. So these two, I don't know why it's not working. It's annoying. So these two are now the same. So that's f of negative x, which is here on my right. So this is f of negative x. And negative f of x are the same. And you proved it algebraically, showing that f of negative x is the same as negative f of x. Anything else on topics 1 through 4?
I think I'm good.
You're good. Ohm's good. Does anybody else have any questions? If you don't, I'm gonna stop recording it. I will put this on the agenda so that you guys can go back and see it.